So I'm giving you a quick tour how to set up the ImSwitch in order to reconstruct the data we are acquiring right now. And so there is the possibility to run ImSwitch from Visual Studio Code. There will be more information how to set it up in the show notes. What's important though is that you have a setup specific configuration file that lists all the different hardware components like the camera, the LED, etc. and also the modules for the reconstruction in order to get ImSwitch to understand what you're aiming for. So what we have in here is you have the ESP32 with the CNC shield and the LED connected to the 3 volts, so there's nothing to switch on and off. And here we have the camera which is connected through USB 3, so we connect it to our laptop. And in this case it's a light vision Wimber camera, and so we are trying to construct the setup file now. So there's also an online repository under GitHub Binary that lists all the different configuration, for example which camera or stage you want to use in the in the UC2 framework. And so we set it up now. So there's one file that's called example _UC2 Holo Wimber. And we are going to use that. So we have the camera manager. In this case, we call it Holo Camera. And we have a manager name, in this case AV for Alight Vision, and certain aspects like exposure stuff and so and so. And what's important here is the widget, the Holo widget, which actually is in charge of reconstructing a hologram. So once this is all set, as said, it's also part of the system here. So if you go to ImControl setups, there's one that's called Holo, and you can just use the Wimber Holo and replace the camera detector with the one from ThorCam. That's it. And then you also have to get ImSwitch to understand that we want to use this configuration file and not another one, for example, for stat or whatever. And so there's another file that's called ImControl options. And so we have to make sure that the setup file name is actually what's a dictionary. So we just rename the default one, and we give the setup file name the name of what we are going to use now. So it's example UC2 Holo Wimber. And then we are going to start the software by essentially going into debug or in run mode inside the main. Here it's still running, so we're just stopping it, and then we press F5 to start the main file. In this case, everything is set up correctly so that it starts. Of course, you have to install the drivers accordingly. It will take a while. And so what we are going to do now essentially is we assume that we have a point source here. Since we filter the LED by the pinhole with spherical waves that propagate, they will illuminate our sample here, and then they will scatter partially, and also some of the light will just go through, and the interference from the scattered and unscattered signal on the camera can be processed by means of a filter back propagation that's actually implemented in ImSwitch. And so what you then do basically is you propagate the field that you assume having on the camera chip, which is an intensity, so we square our amplitudes. We just assume that we have measured the amplitudes and back propagated a certain distance so that we land in the sample plane. And so the holographic plugin here has a small slider that changes the distance with which you propagate between the different planes. So we are going to start over again. So we will again start the live view, and the reason why there is widescreen is because here in this case the dark or the black level is set to a very high level. I think we don't need that for now. In general, it's good practice. Don't put it to 0, but now we just do it for now. We turn on the LED again. I just unplugged it, so we do that now. And what you see here, so we increase the exposure time a bit. Okay, it's very, very bright. So we exposure time, let's go to some level that's not overexposing. So what you may see eventually is some spot here that's absorptive. In this case, I just have a leaf, so it's not very spectacular. And what we're going to do now is we try to reconstruct it, or better refocus that. So we minimize these pictures here so that we see it a little bit better. So what you can do is, like, if you don't see this kind of image, play with the position of the pinhole so that you see. So I just move it a tiny bit. So the pinhole has to be very centered with respect to LED, to the LED intensity peak in the center, and then also find the spots of the sample that's somewhat interesting, like the leaf here. So I should maybe put that to the center, and then we show the Holo reconstruction. So you see that as an overlay, so it appears as a second Napari picture here, or layer, and so we can just switch the other one off so that we see this one in focus, or like in the center. And when we tune the focus, you already see that you can numerically refocus the dust that's sitting on the cover slip. So you see at one point the spots here become very small, and so that means you are in focus with respect to the dust. So you can refocus, and then they go away again. And the rings, that's an artifact from the inline holographical setup. So this is just due to the method itself. So let's try to bring the sample itself to the focus, or to the center. So we don't reconstruct the entire field of view, since this would take very long. I'm just trying to convince the sample to eventually come to the focus here, or to the field of view, more or less. Sorry for my bad terminology. So we're going to switch off the raw data again, go in here and see whether we can create a sharp edge of the leaf. So in general, the leaf itself is highly absorptive, so you won't see so much. But eventually at one point, the leaf shape becomes a bit more sharp. So eventually, right at the end of the slider, we are lucky to focus it. So we may tune the pixel size. This is all good, so maybe the wavelength, but I think this is also fine. Yeah, so this is what you can expect. So maybe we try another sample to get a better result. Okay, third chance. So we have the flower from the valley. We just sneak it in now and see first at the raw data. Zoom out so that we have the whole slide. This actually has not only the sample itself, but also the dust. So eventually we see the dust. So we just insert that, and you already see lots of dirt. So we may put that in here from the side. I think with this we are much more lucky, because you see already the fringes here, the interference patterns around the little point sources or point scatterers. So now let's go back to the show holo, and to the, so we activate the holographical region of interest. And yeah, so the black spot in the center, that's definitely the root of the flower from the valley, but there's not enough light going through, or the background is just way too high. So we can at least refocus the dust here by manipulating the slider. So you see this is roughly the raw image, and then when we tune the slider, we end up with small point scatters that belong to the dust particles. You see that here. So there's some dust strain here, some dust particles there, and yeah, that's what you can do with inline holographical microscopy. I think you can improve the quality quite a bit when you shade the whole setup. So I just put up my pullover so that there's no stray light. So as I said, so if you have anything that's blocking stray light, for example, from the window right there, the contrast will significantly improve, and also the signal to noise will be much better. So let's see. So we have lots of dust here. I think we cannot focus on the root, unfortunately, but still the dust will be in focus. So switching back to the hologram reconstruction, and you see these little dust particles. So the camera sees that, and so when you refocus, you can then tune the focus so that you see individual dust particles in focus. And I think for example, diatoms in the sea, that's quite nice because you don't need any optics, only computational methods to reconstruct data.